All right, ready for lesson 9.3, surface area of cylinders. Our state standard, again, is standard 7G6, which says, I can solve real-world and mathematical problems involving areas, surface areas, and volumes of 3D figures. So we're mainly working with surface area at this point in time. In this case, surface area of a cylinder. As we look at this lovely cylinder, it looks like a can of green beans, a can of pop, my coffee mug. If we find the net of this, slice this down and lay it flat, we have the top and bottom, our two bases, and we have the lateral face, which in this case turns out to be a rectangle. Surface area of a cylinder is 2 capital B plus CH. CH, where capital B, again, is the area of the base, which is a circle, pi r squared, and the circumference of the base, pi d, to find circumference, h being the height of the cylinder. Here we go. Find the surface area of that cylinder. 2 capital B plus CH. Off to the side, capital B equals pi r squared, 3.14 times my radius of 3, if I have a pen that writes, pencil. So I'm going to take 9 times that, and I get 28 and 26/100 inches squared. My circumference, pi, 3 and 14/100, times my diameter. Well, if the radius is 3, the diameter is 6, giving me a circumference of 18 and 84/100 inches. So we substitute that in. Surface area equals 2 times 28 and 26/100 plus circumference 18 and 84/100 times my height of 4. 56 and 52/100 plus 75 and 36/100, 131 88/100, but the directions say to the nearest 10th. So my surface area to the nearest 10th, 131 and 9/10 inches squared. Surface area of that cylinder to the nearest 10th. 2 capital B plus CH. Capital B, pi, 3 and 14/100. Radius, now, they gave me diameter, so my radius is 10 squared, giving me a base area of 314 centimeters squared. Circumference, 3 and 14/100 times diameter of 20, which makes it 62 and 8/10 centimeters. Now you could have the 0 on there too, but if you punched it in your calculator, that 0 is not going to show. If you do it longhand, there'll be a 0. So surface area equals 2 times 314 plus circumference 62 and 8/10 times a height of 30. 628 plus 1,884. 2,512 centimeters squared. You find your area of your base, find your circumference of your base, substitute them in, do the arithmetic. Again, remembering our standard real life and mathematical problems involving surface area. Now, this one's a little trickier. It says, find the lateral surface area of the cylinder. Do we remember what the lateral surface area is? Now, this cylinder looks a little different than the others. It's laying flat on its side. So it's kind of like a propane tank or an anhydrous tank that farmers use this time of the year. It's laying flat, but that just means it has a diameter of 4 and a height of 6. Heights don't always go up and down. Sometimes they go horizontal. Lateral is just this area around, not the two bases. So my lateral surface area is only CH. So my circumference, pi d, 3 14/14, my diameter of 4, 12 56/100 centimeters. So my lateral surface area is 12 56/100 times a height of 6. Punch that into my trusty calculator. And I get 75 36/100 rounded to the nearest tenth. Lateral surface area of 75 4/10 centimeters squared. Now, this next one, you're spending 7 cents to recycle a can with a radius of 3 and a height of 4. What if we would recycling, typo, sorry, a can with a radius of 2 and a height of 6? How much would we get? Assuming that the recycle value is proportional to surface area. So what I have to do is find the surface area of both. So I'm going to go up here where I have a little more room, and I'm going to draw my first can. It has a radius of 3 and a height of 4. So my surface area, 2 capital B plus CH. My base would be pi, 3 14/100, times my radius of 3 squared. So my base would be 28 26/100. My circumference would be pi, 3 14/100, times diameter of 6. 18 84/100. So my surface area of that first can, 2 times 28 26/100. My circumference, 18 84/100, times the height of 4. 56 and 52 hundredths, 75 and 36 hundredths. So my total surface area is 131 and 88 hundredths inches squared. So that's can number 1. Now I need to find can number 2. So I'm going to go down here now and find can number 2. It's a little bit taller. It's got 6 inches and a diameter of only 2. So it's not quite as wide, but it's taller. So surface area, 2 capital B plus CH. My base, area of the base, pi, radius of 2 squared. So we get a area of 12 and 56 hundredths. And circumference of that base, pi, 3 and 14 hundredths times diameter, 4. Oh, look, 12 and 56 hundredths. But one is labeled inches squared, one is labeled inches. So they're a little different because they have different labels. So 2 times 12 and 56 hundredths plus 12 and 56 hundredths times height of 6. So my surface area of this can is 25 and 12 hundredths plus 75 and 36 hundredths, 148 hundredths inches squared. So that's the surface area of can number 2. Now, the first can's bigger. I get 7 cents for that can. What am I going to get for the second can? It's smaller, so I'm not going to get as much, but they are proportional. Proportional means I can write ratios, dollars to area. So 7 cents for 131 and 88 hundredths inches squared would be how much for 148 hundredths? And how do we solve a proportion? We double cross. So cross this way, 7 decimal 0.336 equals 131 88 hundredths x. Divide by 131 and 88 hundredths. Divide by 131 and 88 hundredths. And you get decimal 0.5 rounded to the nearest penny. So for that second can, we should get 5 cents. Again, our standard with our vocabulary of surface area, area of the base, circumference of the base. I can find surface area of cylinders. I can solve real life problems.